Hello, welcome back to the Leukopak Lady. This week I'm doing a short 2-episode series on cryopreservation, how it can contribute to variability in starting materials, and how some in the industry are addressing this by creating cryopreservation hubs. So in past episodes, I've talked about how differences in donors and collection practices can create significant variability in the leukopacks used for research, process development, and the manufacture of clinical allogeneic cell therapies. But there's another source of variability that I haven't covered as much, and that's the cryopreservation process itself. Cryopreservation can actually help normalize some of the variation in collected products. By freezing and thawing the cells, the starting point for manufacturing is better standardized, giving cells time to recover before they go into culture. And this can level the playing field for variable starting materials, especially for therapies made from hardy T cells. When the quality of collected leukopacks are similar, meaning the PBMC purity is high and the contaminants are within established limits, you'd think the downstream performance of the cells would be predictable. But cryopreservation introduces a whole new layer of variability, and here's why. Freezing high concentration cellular products like leukopacks or bone marrow isn't the same as freezing a tube of cultured cells inside a research lab. It takes real skill and training to do well. It uses controlled rate freezers and detailed freeze programs, which are multi-step temperature curves designed to protect the cells as they cool. The problem is, these programs are incredibly sensitive. If the timing or temperature drifts even a little, viability and function can tank. And then there's the culture of secrecy. Freeze programs in this industry are treated like top secret nuclear launch codes. Everybody's running some version of the same basic curve, but when someone finds a way to improve it, they lock that knowledge down inside Fort Knox. And this is the kind of unnecessary cloudiness that makes standardization so hard, and why cryopreservation can introduce variation even when everything upstream looks the same. And because everyone has similar training and is running almost the same freeze program, but it's not quite the same from center to center. And don't even get me started on thaw protocols. These are the least standardized of all procedures in cell therapy. The collected product could be great and the cryopreservation done to perfection, but if the thaw is not done carefully and consistently, all that great work that came before it is useless. So if cryopreservation itself can add variation, what's the solution? To tackle that challenge, some cell therapy developers are bringing the cryopreservation step in-house so they can control this variable on their own terms with their own protocols, taking it out of the hands of collection centers altogether. Other companies are establishing regional cryopreservation and cold chain logistics hubs to process leukopacks from multiple collection sites using standardized protocols. And I love both of these solutions, and I think they're really good for the industry. On the next episode, we'll take a closer look at these hubs, why they're popping up, and how they can help make cryopreservation more consistent.